Welcome to the Explainer. Okay, let's dive into this, because today we are exposing a massive hidden issue, and I mean massive. It is quietly destroying customer trust and literally burning revenue inside almost every payment system built before 2020. I'm talking about the machine that decides whether your credit card transaction goes through or it gets declined. You know, it runs every second of every day, making millions of decisions, and right now, it's making the wrong call. $118 billion. That is the staggering annual cost of what the industry calls false positives in the US alone. But hold on. Let's be crystal clear about what a false positive actually is here. This isn't money stolen by hackers or scammers. No, this is $118 billion completely lost by companies blocking their own perfectly legitimate customers who are just trying to hand them money.
And this brilliantly illustrates the sheer absurdity of the whole situation. For every single dollar a company loses to actual fraud, they are losing $13 by accidentally blocking the wrong person. 13 to 1. Think about that. The very system designed to protect a business's revenue is actively destroying 13 times more than it saves. It's just a complete paradox.
Which brings us to Section 1, Anatomy of a Broken System. Let's look at exactly what lives inside these legacy payment companies and why it's failing so spectacularly.
So how do we actually get here? Well, inside most of these legacy companies is something called a rules engine. It's essentially this giant rigid checklist written by programmers years ago. The logic is incredibly blunt. It looks something like, if a transaction is over $500 and the location differs from the registered address, well then, block. It's completely static. It has absolutely zero memory of what happened yesterday versus today. And as we all know, a static system simply cannot survive in a dynamic, ever-changing environment.
Let me make this abstract data real for you. Meet Priya. She's a totally legitimate customer who just relocated from Mumbai to London for a new job, and she tries to buy software for her work. The legacy rules engine looks at this and sees a new city, a different country, a large amount, and an unfamiliar device. The result? Blocked. Instantly. She's right by every human measure, but the static system flags her anyway. And in the 8 seconds it takes for that decline message to pop up, the company just evaporated $2,000 to $4,000 of Priya's lifetime value. She's embarrassed, she's frustrated, and she's definitely taking her business somewhere else.
To really grasp the true scale of this, let's look at a composite company based on real industry data. We'll call them Viridian Pay. They were processing about 500,000 transactions a day with a 2.3% false positive rate. That meant they were blocking 11,500 real people, exactly like Priya, every single day. 11,500 legitimate customers just turned away at the door because a system built in 2018 said they looked kind of suspicious.
Moving to Section 2, the technical paradox, 3 impossible constraints. Let's talk about why we can't just easily fix this. Now, you might be wondering, why not just use AI to fix it? Well, it's not quite that simple. The first constraint is speed, specifically something called the blink budget. A payment system has this extremely strict requirement to return a fraud decision in under 30 milliseconds. That's before a user even perceives a lag on their screen. So if you have an incredibly accurate AI model but it takes 500 milliseconds to think, it's entirely useless. Why? Because after half a second, users think the site is broken and they abandon their carts. Every single millisecond in this pipeline is load-bearing. The second constraint is explainability. This is a massive regulatory mandate. If a transaction is blocked, the compliance team absolutely must be able to explain exactly why in plain language. Under laws like GDPR, you cannot just tell regulators or customers, well, the AI said no. That doesn't fly. The system must be fully auditable, and it has to show its work every single time.
So, the crucial point is really captured in this third constraint, class imbalance. Only 0.1% of transactions are actual fraud. 99.9% are perfectly legitimate. If you just feed this highly skewed data into a standard AI model, it quickly learns a lazy trick. If it just says not fraud to absolutely everything, it will technically score 99.9% accuracy. Looks great on paper, right? But practically, it misses every single scammer. It just takes the easy way out.
Let's look at Section 3, Building a Better Brain. This is the modern continuous learning architecture that Viridian Pay used to solve those exact impossible constraints.
So how exactly do you solve a problem that needs to be lightning fast, fully explainable, and perfectly balanced against this massive data skew? Well, instead of a static checklist, Viridian deployed a combination of light GBM and SMOT. Let's ditch the heavy jargon for a second. Just think of light GBM as a massive committee of decision makers that actually learns from previous mistakes, evaluating hundreds of behavioral signals all at once. And to fix the data imbalance, they used SMOT and cost-sensitive learning. Essentially, they explicitly forced the AI to understand that missing a fraudster and blocking a real customer are both highly costly. They forced it to balance the scales rather than just chasing a cheap accuracy score.
Let's move to and see how this builds out in reality. Here's the really elegant three-step architecture they constructed to beat that 30-millisecond clock. Step 1. A feature store that pre-calculates user behavior in just 20 milliseconds. Step 2. The light GBM model makes the actual fraud call in 8 to 12 milliseconds. In Step 3, a SHAP explanation layer runs in under 10 milliseconds. It evaluates, decides, and explains the whole thing, all literally within the blink of an eye.
Now, what's really interesting about this slide is the exact output from that third layer, the SHAP tool. Just look at this clear explanation. Flag primarily because merchant category not in 90-day history, amount is 4.1x higher than rolling average, and device ID is new. This proves that explainable AI translates complex, multidimensional math into a totally clear, auditable compliance answer. The compliance team doesn't get some mysterious black box, they get a readable, human-friendly receipt.
Which takes us to Section 4, the transformation and the future of fraud. Time to look at some dramatic before and after results. We've seen the impressive mechanics, so let's look at the actual business impact. When you turn your compliance team from a gatekeeper into a co-designer, the before and after results are just dramatic. Back in 2018, the old rules engine had a 2.3% false positive rate, wrongly declining 11,500 people a day with absolutely zero ability to learn. But with light GBM and SHAP, the false positive rate completely plummets to 0.4%. The wrong declines drop to 2,000. And the best part, it is continuously learning every single week. They achieved this massive drop in false positives without sacrificing an inch of fraud detection. And here is the real logical and emotional climax of this entire explainer: $295 million. Just by allowing 9,500 more real customers, people like Priya, to complete their purchases every single day, Viridian Pay recovered almost $300 million in annual revenue. No way, right? They didn't even need a new marketing campaign or a new product launch. They literally just had to stop their own legacy system from kicking real customers out of their store. But, fixing false positives is really only half the battle, and the clock is ticking for everyone. Right now, there is an explosive 1,210% surge in AI-enabled industrialized fraud attacks compared to a 195% rise in traditional fraud. Fraudsters are out there using deepfakes, synthetic identities, and pure automation to attack at scale. If your business is still relying on a static rules engine against an adversary that constantly generates new attack patterns, that engine isn't just outdated anymore, it is a massive, critical liability. So, let's lock in our strategic takeaways from everything we've covered today. First, remember that the false positive problem is the exact same thing as the fraud problem. They are quite literally two sides of the same coin. Second, avoid static 2018 rules engines at all costs. Just don't do it. Third, use battle-tested tools like light GBM and SHAP. These are not experimental frontier tech anymore. They are absolutely the new baseline infrastructure for this decade. And finally, bring your compliance team in as co-designers right from the very start. I want to leave you with a question to really chew on as we wrap up this explainer. Can your machine learn automatically, or is it just following static rules while quietly declining your real customers? Think about your own business or even the platforms you use every day. Is there a legacy machine sitting in the dark, quietly destroying revenue and customer trust, simply because it doesn't know how to learn? Thank you so much for joining me today. Now go ask your team the hard questions.